Sweet, so now we're going to do the backwards order of this transformation list. Just as a reminder, I've kept this here. This is the image after the original order. Y is equal to negative square root of 1/2 of x minus 4. So you can see that we can kind of visualize how each of these transformations or each of these, individual transformations are represented here. So now we're going to do the opposite order and see how the actual final result is different. So we're going to start off with the translation of 4 units in the positive x direction. So we're going to use the same process as last time, x comma y. That's going to become x plus 4 comma y. Then after that, we're going to apply the reflection in the x-axis. Now, what that means is that our y value becomes negative, so that's the same as last time, x plus 4 comma negative y. And then the last one is the dilation by a factor of 2 from the y-axis. So what we do is we take our full x term here, and then we multiply it by 2, because this was the x term at the previous step. So therefore what we do is we take 2 multiplied by x plus 4 completely outside of negative y. Sweet. Now usually you would apply it in the order that's given in, but I just should have maybe explained this at the start. I just couldn't be bothered rewriting this, so I just said we're just going to go 3, 2, 1 instead of 1, 2, 3, just to do the opposite order as the previous part of this video. Sweet, so now we have expressions for x dashed and y dashed. So what we're going to do is just write them out. X dashed is equal to 2 multiplied by x plus 4 inside of a bracket. So that's going to become 2x plus 8. And then y dashed is equal to negative y. Now, if you compare these expressions to the expressions from the previous part of this video, there's actually only one difference in this case. And it's that we have plus 8 instead of plus 4. And if you think about what we've actually done with our transformations, it actually should be it should be slightly obvious why this is happening. Or if you just think about what we've actually done, you can see that what we've done is we've translated and then we've applied our dilation. So what our dilation has actually done, because we've done it post-translation, is that our dilation has stretched our translation. Our dilation has stretched our translation. Yeah, that makes sense. So what we've done, we've translated our graph by 4 units, but then we've stretched in that direction by another factor of 2. So what it's done is it's stretched the translation from 4 to 8. So that's why we have a plus 8 here. And that's why our transformation or our image equation is going to be represented differently after we apply these transformations. Cool. So let's go ahead and find our actual equation and see, what kind of pops up. So what we can do is rearrange for normal x and y. So what we get is x is equal to x dashed minus 8 over 2. And then y is equal to negative y dashed. So equation 1, equation 2, pop that into y is equal to the square root of x. We end up getting negative y dashed is equal to the square root of x dashed minus 8 divided by 2. Therefore, y dash is equal to negative square root of 1/2 outside of x dashed minus 8. And then we do our usual thing where we specify the image of the same equation without the dashes. But I'm just going to leave it for now. But what we can see is that if we just compare these two equations, so this is the image of this equation after the reverse order, this was the image of the equation after the normal order, 1, 2, and 3. And again, as you can see, the only difference is our translation value in the x direction. Here, it's 8 units. Here, it's 4 units. And the only reason for that difference is because of the translation happening before the dilation. So the dilation has actually stretched our translation value. Now, what's interesting to note is that you can get a unique list of transformations that is different to the list that we applied above, but it gives you the same result. So what I mean by that is we can apply a dilation by a factor of 2 from the y-axis, which gives us this. And then we can apply a reflection in the x-axis, which gives us that. And then we can apply a translation of 8 units in the positive x direction to give us that. And that would give us the same in the order that I specified as this order here, the translation of 4 units, then the reflection in the x-axis, and then the dilation by a factor of 2 from the y-axis. It would give us the same result, or the same image equation after applying those 2 different transformation sets, which is unique to note because you can see there's infinitely many ways of applying the same set of transformations to get the same result. But first of all, it does depend on your equation, and second of all, it does specifically depend on the order of your transformations as well.